Innovation is an extremely interesting thing to the extent that you can either innovate forward from what there is, or you can innovate backwards from a problem. But grids are really only made up out of wire and transformers historically. So what we need to see here is the kind of scale of transition that there was with the implementation of the internet, from switches and copper wire to routers in those nodal locations which the switch used to occupy. That changes the way that that same grid can actually function. Well, we're seeking to achieve the same thing. If you can deliver energy from anywhere to anyone, then you have to have a device which is bidirectional in its nature and maintains the integrity of the alternating current waveform itself, because that's what we share across our economies, our societies. That's what underpins the lives we live today. So if I no longer have spinning mass generators to be able to provide the stability of the signal, I need to get that stability and the power quality necessary. So we set out to take all of that information and work backwards to define exactly what would be the ideal device which sat in that location and enable the grid to function in the most optimal manner with the most optimal signal at all times. And that's what we've delivered.
My current focus is on the Prime Exchanger. First of all, we had to solve the math. Three-phase transformers have been the backbone of electrical power distribution for about 130 years. And we are giving this class of devices completely new capabilities that cannot be found in any textbook. The next step was simplify. Simplify again and again, It needed to be translated from pure math into something that can actually run on a tiny processor chip. Creating a solution that is known to be correct, that was the final step. The big differentiating factor is that we can do what is called load balancing. Their 130-year-old technology just cannot deal with this new kind of connection.
Prime Exchanger is incredibly new. It's designed from the ground up. It's been ages since anybody thought about the physics of the device. There is a different worldview, and we are bringing that worldview. The greatest hope for our technology, I think, and we can meaningfully reduce the cost of energy as delivered to end consumers.
I think the most unique part is the simplicity of the devices itself. We can realize so many different functions just with a three-phase torus. So I basically using 5D element software to do the simulation work, including the devices modeling, the winding optimization, and also to make sure the model is liaised with the mathematical model that I have done in the background.
To be able to reinvent processes across an enormous range of outcomes requires such willingness in a working relationship. So it comes down to humans at the end of the day, working together to solve how do you achieve this new form, how do you achieve this new solution, how do you do it at the lowest cost of production, and how do you do it in a manner in which the supply chain wins, Enoda wins, but ultimately the consumer wins because we're able to solve the problem at scale.
The key responsibilities for a lead manufacturing engineer are really the productionization of the development system, of the prototype systems, and how we scale that up.
I've spent my professional career in the grid space. Ever since my PhD, I've been in that area, and grid is very rarely the topic of discussion in the energy industry, in the electrical energy industry. It's usually about suppliers, and it's usually about demand and supply. The grid has a great role in making the connection between the suppliers, the generators of energy, and delivering it to end consumers. And with our technology, we are making the grid active part in that ecosystem that's never been done before.
Ensemble is a platform that allows for multi-sided markets to be formed, allowing prosumers, microgrids, Enoda agents, DNOs to participate together in a marketplace that allows for the buying and selling of energy. Blockchain means different things to different people, but for us it means decentralization. So the first step is obviously scoping out the design. So we have a very talented team here, multidisciplinary team. We have computer scientists, blockchain engineers, blockchain architects. So we are currently scoping out and building test nets to understand how different types of machine-to-machine protocol would work. The goal of Ensemble is to really connect as many people as possible. Enoda's defining goal is sustainable prosperity for everyone. Ensemble is going to allow us to open up previously closed access to energy markets.
At Enoda, we're not just rearranging deck chairs on the Titanic. We're actually creating technology to disperse icebergs. This is not pie-in-the-sky kind of technology. We want radically better capabilities than what the utilities have in their existing equipment, and we want to make sure that it works every day, 24/7, 365.
So if we remember how big the challenge is, almost the entire world's population uses the system we're talking about. To be able to change that, step one, have the technical capacity to be able to change that, solve that problem. That's done. Now the challenge is all about scaling to the kinds of volumes which really move the dial so that energy is clean, it's affordable, and it's reliable for everyone on a global basis. And that challenge is where we focus our attention today.